Good morning, everyone. A very warm welcome to today's ISACA Innovation and Tech Talk. My name is Nora. I'm the head of Innovation Tech Talk Working Group, and I will be guiding you through today's Tech Talk. Before we begin, I would like to extend a special very welcome to our speaker, Mark. Mark, thank you very much for taking the time to join us today and for sharing your expertise with us. We truly appreciate your contribution. For today's topic is Leading with AI, How Leadership Shapes Trust, Explainability, and Governance. So we are very much looking forward to your insights. But before we start, some very important notes. This event is being recorded and will be made available after the session at ISACA's homepage. A CPE certificate will be sent approximately 2 weeks after this event. And please, if you have any questions during the session, you can submit them via the chat function. And for feedback, suggestions, or requests, please contact our mailbox. And also we have our podcast available on the homepage from the ISACA. With that, Mark, I would now like to hand over to you. Thank you very much.
Good morning, everyone, and welcome to this ISACA Tech Talk from my side. Let me start with a simple observation from practice. When AI-supported decisions fail in organizations, it is almost never because the model was too complex or the explanation was too weak. What usually fails is something else. Leadership did not clearly define who is really responsible, how much the AI should be trusted, and what happens when the system is wrong. Today, we talk a lot about explainable AI. We invest heavily in transparency, dashboards, and model interpretability. But explainability alone does not create a trust, and it does not prevent blind reliance, silent workarounds, or unclear accountability. My core argument today will be very simple. So trustworthy AI is not primarily a technical problem, it is more a leadership and governance problem. In this talk, I will show why leadership plays a central role in shaping trust, explainability, and governance in AI-supported knowledge-intensive work, such as audit, governance, and information security. Before we go into the content, let me briefly walk you through the structure of the talk. In the first part, I will set the stage by outlining the motivation, the research context, and why trust in AI is such a relevant issue in high-stakes decision environments. In the second part, I will briefly explain the methodological foundation so you understand where the insights come from and why they are grounded in systematic research. The third part is the core of the talk. Here I will present the key findings on leadership, trust, and explainability, and explain why leadership acts as a central mechanism in AI-supported decision-making. In the fourth part, I will translate the findings, which I founded from the studied literature into practical implications for audit, IT governance, and information security. And finally, I will close with a small set of key takeaways. So in the first part, I want to frame the problem we are dealing with. I will outline how AI is currently used in knowledge-intensive decision-making and why trust has become such a critical issue. And we will also talk about why leadership plays a much bigger role than it is usually given credit for. Before we go into the substance, let me briefly introduce myself and the context of this research. My name is Mark Bongartz. I work as a manager in IT audit and information security, and my professional background is strongly rooted in audit, governance, and assurance-related topics. In my current role, I work intensively with IT audits and information security engagements, including C5 audits, ISMS implementations, and also migration-related assurance. These are exactly the kinds of environments where AI is increasingly used to support complex and also high-stakes decisions. From April onwards, I'll be working at Picker Fasselt, where I am responsible for information security and AI-related governance topics, also including C5, NIST-based frameworks, and assurance around AI-enabled systems. In parallel to my professional work, I completed an MBA in Management and Leadership, which I finished in 2025. During this MBA, I focused intensively on leadership, decision-making, and organizational dynamics. At the same time, AI was becoming more prominent in my professional work, particularly in audit and information security context. This raised a very practical question for me. So how leadership decisions influence how people trust, use, and govern AI-supported decisions? That question ultimately led me to pursue at the University of Twente, where I doing my PhD. So my research focus on how leadership shapes trust, explainability, and governance in AI-supported knowledge-intensive work. This combination of practice and research is important for today's talk. The ideas I will present are not purely theoretical, but grounded in a systematic research and in real-world audit, governance, and information security context that many of you will recognize from your own work. So let us start with how AI is actually used in audit, governance, and information security today. When we talk about artificial intelligence in organization, we often think about automation and efficiency. However, in many of the environments we presented here today, AI is increasingly embedded in knowledge-intensive decision-making. This includes audit planning, risk assessment, compliance monitoring, and security analysis as well. These are not routine tasks. They involve professional judgment, uncertainty, and accountability. In this context, AI does not replace human decision makers. It influences how judgment is exercised. And once AI becomes part of high-stakes decision processes, the relevant question shifts. It is no longer only about performance, it becomes more about how these decisions remain governable over time. And this brings us directly to the question of why this matters so much for ISACA practitioners. From an audit, governance, and information security perspective, this transformation has concrete implications. In traditional governance models, authority and accountability are clearly mapped. A decision is made by a person or a committee. That decision can be reviewed, challenged, or traced back. When AI becomes part of the decision architecture, this clarity can become blurred, not because responsibility disappears, but more because influence becomes distributed. An AI system may not formally decide, but it can strongly shape which options are considered and which are ignored. In audit context, this affects professional skepticism. In security context, it affects incident prioritization. And in governance context, it affects risk classification and escalation logic. If influence and accountability drift apart, governance gaps can emerge. This is not necessarily a failure of the technology. It is often a misalignment between technological integration and organizational oversight. For ISACA practitioners, this means that AI governance cannot be reduced to model validation or compliance checklists. The key question becomes whether AI-supported decisions remain embedded in stable responsibility and control structures. To understand this more deeply, we need to look at the trust problem that sits behind many explainable AI initiatives. Explainable AI is widely discussed as a technical solution to trust problem. The dominant assumption is that better explanations automatically lead to higher trust. However, existing research provides surprisingly limited insight into how trust actually emerges and stabilizes in organizational context. Trust is not only about understanding how a model works. It is also about expectations, responsibility, and the ability to question or override decisions. Leadership is often acknowledged in this discussion, but usually only as more background context, not as the central mechanism behind it. In practice, however, leadership strongly shapes whether explanations support professional judgment or whether they function as authority signals that discourage critical thinking. This is particularly relevant in high-stakes environments such as even audit, governance, and information security, where decisions must be defensible and accountable all the time. This gap between explainability and trust leads us directly to the core research question behind this work. Building on this gap, the research shifts the analytical lens from the system to the surrounding decision architecture. The central question is not whether explainability AI is useful. The question is more how trust in AI-supported decisions is shaped within organizational contexts where authority, hierarchy, and responsibility already exist. More specifically, the research examines how leadership practices influence the integration of explainability, authority, and accountability in knowledge-intensive environments. Leadership is particularly relevant because it operates at the intersection between technology and the organizational structure. Leaders determine how AI outputs are positioned within workflows, how much weight they carry, and how deviations are threatened. The analytical scope, therefore, focuses on decision architectures rather than model architectures. It asks how authority is allocated, how explanations are interpreted, and how responsibility is structured in practice. For ISACA professionals, this perspective directly affects audit design, governance assessment, and information security oversight. On the right-hand side of the slide, you can see a photo of the University of Twente campus where this research is based. It gives you a small impression of the academic environment behind this work. So, to examine this question systematically and avoid purely anecdotal conclusions, the study is grounded in a structured methodological approach, which I will briefly explain next. In the second part, I will briefly outline the methodological foundation of the research. The goal here is not to go into academic detail, but to give you a clear understanding of how the findings were derived and why they are systematic rather than anecdotal. The literature was analyzed using a structured analytical framework that focuses on decision-making rather than on technical model properties. Each study was examined along three core dimensions: trust, explainability, and leadership. For trust, the analysis looked at how trust is defined and operationalized. So the question is trust threaded as reliance on outputs, as perceived accuracy, or as broader judgment about responsibility, legitimacy, and accountability? For explainability, the focus was not only on whether explanations exist, but on how they are framed and used. So here's the question: are explanations designed to support professional judgment, or do they function as authority signals that discourage questioning? Leadership was the key analytical lens. The central distinction was whether leadership is treated as a passive context, for example, organizational culture or management support, or more as an active mechanism shaping how AI is used in practice. This distinction is critical for ISACA-related domains. In audit, governance, and information security, it is rarely the absence of controls that causes the problem. Instead, issues arise when decision rights, escalation paths, and accountability are not clearly defined. By systematically coding these aspects across the literature, the analysis identifies recurring patterns, dominant assumptions, and blind spots. To ensure consistency across studies, a clear analytical framework and coding logic were applied. The analytical framework shifts attention from the AI system itself to the decision architecture surrounding it. Instead of asking how a model works initially, the framework asks more how AI is embedded into the organizational decision processes. Concretely, the analysis focused on four recurring elements. First, the allocation of decision rights between humans and AI. This includes whether AI provides recommendations, supports judgment, or effectively replaces human decision-making. Second, the framing of explanations. Explanations can be used as reasons that enable understanding and contestation, or as authority signals that legitimize decisions without scrutiny. Third, the handling of uncertainty errors and dissent. This includes whether questioning AI output is encouraged and how errors are detected and escalated. Fourth but not least, accountability and governance structures. So here, the question could be, who is responsible for the final decision? What is documented, and how are decisions made auditable and traceable over time? From an ISACA perspective, these elements are highly relevant because they translate abstract concepts like trust and explainability into accessible governance practices. With this methodological foundation in place, we can now turn to the results of the review and examine what the literature actually tells us. In this third part, I will present the core findings so far from the systematic literature review. This is where the different research streams come together and where leadership emerges as a central mechanism shaping trust and explainability in AI-supported decision-making. Let me start with the dominant research stream that shapes how many organizations currently think about trust in AI. In the literature, the most common assumption is quite straightforward. If we make AI more explainability, people will trust it more. That is why explainable AI, or XAI, has become such a central topic. The idea is that explanations make model behavior more transparent so users can understand why a certain output was produced. In this stream, explanations are often treated as a cognitive tool. They are meant to help people answer questions like, which factors mattered most? Why did the system classify something as high risk? Or what would need to change for the outcome to be different? And to be clear here, this stream is valuable. It has produced practical methods that many of you may already know from tooling and real implementations, like feature importance, local explanations, or counterfactual explanations. However, what the review shows is that this dominant view also narrows the way trust is understood. Trust becomes almost the same thing as understanding the model. The organizational context is then treated as a secondary. Leadership is often mentioned implicitly, maybe as training or user adoption, but not analyzed as the core mechanism that shapes how explanations are used in practice. And this is exactly where the tension begins, especially in ISACA-related domains. In audit, governance, and information security, it is rarely enough to understand an output. What matters is whether decisions are responsible, traceable, and defensible, as I mentioned before. Let me make that concrete. Even if an AI system explains itself well, we still need to know who had the right to decide, who carried accountability, and what happens if the AI is wrong. In other words, explainability can improve transparency, but it does not automatically create governability. So the dominant research stream is important, but it leaves a gap here. It tends to set trust as a technical outcome, while in real organizations, trust is also a governance outcome. And this is the bridge to the next slide. If trust is not only a function of explanations, what else shapes it, especially over time in high-stake decision environments? This is why we need to look beyond explainability and focuses on the broader trust mechanisms where leadership becomes central. Now, this first dominant research stream focuses on technical explainability. Within this perspective, trust is primarily conceptualized as a function of model transparency. The central assumption is that users are more likely to rely appropriately on AI systems if they understand how outputs are generated. Much of this research, therefore, concentrates on interpretability methods, feature attribution techniques, and post-hoc explanation mechanisms. The analytical unit in this stream is the model itself. The main research question typically revolves around high complex algorithms can be made more interpretable without sacrificing predictive performance. Trust in this context is threaded as a cognitive calibration process. If users receive sufficient information about a about the way a decision was produced, they are assumed to adjust their reliance accordingly. What is important to note here is not whether this perspective is correct or incorrect. Rather, it frames trust primarily as a property that can be influenced through technical decision choices. And this is exactly where the next step is to move beyond explainability and look at trust more broadly. Alongside the technical explainability perspective, a second research stream expands the understanding of trust beyond transparency alone. In this literature, trust is not treated solely as a cognitive response to the model interpretability. Instead, trust is analyzed as something that emerges with an organizational context. This perspective recognizes that AI-supported decisions do not occur in isolation. They take place within structured environments defined by authority, hierarchy, and professional norms. When decisions are embedded in such structures, transparency is only one variable among many of them. What becomes equally important is how AI outputs are positioned within workflows, how much authority they carry, and how disagreements are handled. It is precisely at this intersection between technical output and organizational structure that leadership becomes relevant. Leadership determines how AI systems are integrated into decision processes, how reliance is framed, and how responsibility is exercised in practice. In this broader perspective, trust is therefore not only a matter of understanding the system. It is shaped by how organizational actors interpret, legitimize, and govern AI-supported decisions. This shift in analytical lens opens the door to examining leadership as a central structure force in AI governance. The literature points very clearly to leadership as the central mechanism shaping how trust in AI actually develops. If trust goes beyond explainability, the next question is not whether leadership matters, but how leadership actually influences trust in AI practice. One of the most consistent findings across the literature is that leadership shapes trust in AI through a smaller number of recurring influence factors. Importantly, these are not abstract leadership styles or personality traits. The literature does not say that, for example, good leaders automatically create trust in AI. Instead, trust is shaped through concrete leadership practices that structure how AI is embedded into everyday decision making. These practices influence how strongly AI affects decisions, how uncertainty is handled, and how responsibility is assigned. Across different domains and studies, 4 influence factors appear again and again. The first concerns that allocation of decision rights between humans and AI. So leaders determine whether AI systems merely support judgment, provide recommendations, or effectively dominate the decision. The second factor relates to the framing of explanations. Explanations can be framed as reasons that support understanding and professional judgment, or as authority signals that discourage questioning. The third factor concerns the handling of uncertainty, errors, and dissent. Leadership decisions shape whether questioning AI outputs is encouraged, tolerated, or implicitly punished. Finally, these practices translate into accountability structures that determine who is responsible, how decisions are documented, and how oversight is exercised. From an ISACA perspective, these influence factors are highly relevant. They sit exactly at the intersection of auditability, governance, and information security. They determine not only whether AI systems are technically sound, but whether their use is controllable, defensible, and sustainable over time. In the following slides, I will walk you through these leadership influence factors one by one, starting with the allocation of decision rights between humans and AI. So let us begin with the question of who actually decides when AI is involved. One of the most central leadership influence factors identified in the literature is the allocation of decision rights between humans and AI. At this point, the focus is no longer on observable outcomes, but more on the structural mechanism behind them. Decision rights define who is authorized to decide, who carries responsibility, and how authority is distributed between human decision makers and AI systems. The literature shows that in many organizations, this allocation is not made explicit. AI is introduced as decision support, but without clearly defining what that means in terms of authority and responsibility. Over time, this creates a structural gap. AI outputs increasingly influence decisions, while formal accountability remains with humans who may no longer feel in control of the decision process. This gap between influence and responsibility is the core governance problem. It explains why trust in AI becomes unstable even when systems are technically sound and explainable. Leadership plays a decisive role here by explicitly defining the decision boundaries. Leaders determine whether AI informs judgment, recommends actions, or effectively sets the direction of the decisions. From an audit and governance perspective, this distinction is critical. Without a clear allocation of decision rights, it becomes impossible to reliably assess accountability, trace decisions, or evaluate whether reliance on AI was appropriate. The key insight from the literature is therefore not about behavior, but about the design. Trustworthy AI requires decision architectures in which authority and responsibility are deliberately aligned. So decision rights define who decides, but they do not yet explain how decisions are justified. This brings us to the next leadership influence factor, which is how explanations are framed and used in practice. Up to this point, we have looked at structural aspects such as decision rights. This slide shifts the focus to a different dimension, the symbolic and communicative role of explanation inside organizations. Explanations are not only informational, they are also carry meaning. So leadership determines how explanations are interpreted within the organization. When explanations are framed as reasons, they become part of the reasoning process. They invite interpretation, discussions, and professional judgment. In this case, the AI system contributes to a shared understanding, but it does not define the outcome. So when explanations are framed as authority, their function changes completely. They signal legitimacy and correctness. The explanation no longer invites interpretation. It stabilizes the output as something that should not be questioned further. This distinction is subtle, but it shifts where authority resides. In the first case, authority remains distributed among human decision makers. In the second case, authority moves toward the system. This is not a technical effect, it is a leadership effect. Leaders shape whether explanations function as part of deliberation or as an instrument of closure. In governance-heavy environments, this distinction directly affects how responsibility is exercised and documented. The key insight here is not about explainability itself. It is about how meaning is constructed around AI outputs. Even when decision rights are clearly defined and explanations are framed constructively, AI-supported decisions still operate under uncertainty. This leads us to the next leadership influence factor, which is how uncertainty, errors, and dissent are handled in practice. So let us now move from authority and framing to a more operational dimension. How organizations deal with uncertainty, errors, and dissent when AI is involved. The first important point is that AI-supported decisions always operate under uncertainty. AI systems work with incomplete information, probabilistic models, and historical data that may not fully reflect current conditions. This means that uncertainty is not an exception. It is more a structural feature of AI-supported decision-making. Leadership therefore determines whether uncertainty is acknowledged openly or whether it is implicitly downplayed. This brings us to the second point shown on the slide. When uncertainty and errors are suppressed, organizations tend to conceal model limitations and discourage critical reflection. In such environments, people may hesitate to question outputs because they assume the system is more objective or more accurate than they actually are. The literature warns that this increases the risk of silent failures, not because the system is technically broken, but because weak signals are not escalated, doubts are not voiced, and model limitations remain hidden. This creates a form of unmanaged model risk that is difficult to detect from a purely technical perspective. Now the third dimension. In contrast, leadership practices that encourage transparency, structured error reporting, and constructive dissent create a very different dynamic. Here, uncertainty is treated as normal. Questioning is not seen as a resistance, but as a part of responsible oversight. Overrides are documented and escalations are expected. In such environments, AI does not become less powerful. It becomes more governable. This is very important. From an ISACA perspective, this directly affects auditability and incident management. If errors are surfaced early and dissent is structured, organizations are better able to trace decision processes or evaluate risk exposures and demonstrate responsible AI governance. The key insight here is that uncertainty management is not a technical add-on. It is the leadership responsibility that determines whether AI risk remains visible and controllable over time. So when we look at decision rights, explanation framing, and the handling of uncertainty together, we can now see how these practices accumulate into something more structural. They shape the accountability architecture surrounding AI-supported decisions. We have now looked at three distinct leadership influence factors: decision rights, explanation framing, and the handling of uncertainty and dissent. This slide here brings them together, and it shifts the focus from individual practices to something more structural, accountability structures. Leadership practices do not remain isolated actions. Over time, they solidify into patterns that define how responsible is the exercise in the organization. So decision rights determine who formally holds the authority. Explanation framing determines how decisions are justified and interpreted. The handling of uncertainty determines whether risks and doubts become visible or remain hidden. Together, these practices form what we can describe as an accountability architecture around AI-supported decisions. This architecture answers three fundamental governance questions. So first, who is responsible for the decision outcome? Second, on what basis was the decision made? And third, and how can the decision be reviewed, challenged, or audited later on? If leadership practices are inconsistent, accountability structures become fragmented. For example, responsibility may formally lie with human decision makers, but authority may de facto shift toward the system. Or explanations may exist, but they are not documented in a way that makes decisions reconstructible. In such cases, AI governance remains superficial. On the other hand, when leadership deliberately aligns authority, reasoning processes, and escalation mechanisms, accountability becomes structurally embedded. AI-supported decisions then become traceable not only at the technical level, but at the organizational level. From an ISACA perspective, this distinction is critical. Auditability depends on coherent accountability structures. Controls, documentation requirements, and review mechanisms can only function effectively when responsibility, authority, and escalation are aligned. The literature therefore suggests a shift in perspective. Instead of asking whether AI systems are trustworthy by design, we should ask whether organizations are accountable by design when using the AI system. So trustworthy AI is not primarily a property of the system. It is the outcome of a leadership-centered governance model. Rather than looking at isolated leadership practices, this model positions leadership as the integrating mechanism that connects technical explainability with organizational accountability. The core idea is simple but powerful. Trustworthy AI is not the property of the system alone. It emerges from how leadership embeds AI into decision-making structures. As illustrated in the model, leadership operates through three interacting mechanisms that shape how AI-supported decisions unfold in practice. The first mechanism concerns decision rights. So leadership determines how authority is distributed between human decision makers and AI systems, and whether AI outputs remain advisory or become structurally influential. The second mechanism relates to the framing of explanations. Leadership shapes how explanations are interpreted within organizational contexts, either as inputs to professional judgment or as signals of legitimization that stabilize AI-supported decisions. The third mechanism concerns the handling of uncertainty and dissent. Leadership practices determine whether model limitations, disagreements, and ambitious outputs remain visible within decision processes or are implicitly suppressed. Together, these mechanisms connect technical explainability with organizational governance structures and give rise to accountability, oversight, and also escalation routines. The key contribution of this model is that it reframes trust as an organizational outcome. Trust is not generated simply by transparency. It is stabilized when technical systems, decision processes, and governance mechanisms are aligned through leadership practices. From an ISACA perspective, this alignment is critical. Governance frameworks, audit procedures, and information security controls can only function effectively when leadership actively integrates AI into existing accountability structures. If this integration does not occur, organizations may have explainable AI systems without having governable AI decisions. The model therefore shifts the central question. Instead of asking, is the AI system trustworthy? We should ask, is the organization structured in a way that makes AI-supported decisions accountable and auditable again over time? This leadership-centered perspective provides the conceptual foundation for the final part of the talk, where we translate the literature-based insights into concrete implications for audit, IT governance, and information security. So importantly, these implications are not presented as personal recommendations, rather they reflect recurring patterns and theoretical insights that emerge across the analyzed body of literature. The intention is therefore not to prescribe solutions, but to illustrate how existing research reframes the objective of governance. When AI becomes embedded in knowledge-intensive decision-making contexts. Let me begin with audit. The literature suggests that AI-related audit approaches require a conceptual expansion. Within the technical explainability stream, assurance efforts tend to concentrate on model validation or data integrity, bias detection, and interpretability mechanisms. These aspects remain essential. However, the broader research reviewed in the study indicates that model-level assurance does not fully capture how AI influences the organizational decision-making. Several studies emphasizes that AI systems often operate within complex decision environments where authority, professional judgment, and escalation routines already exist. From this perspective, the object of audit shifts here. The focus is no longer if the AI system interacts as a technical artifact. Instead, it becomes the decision architecture in which the system is embedded. So the literature highlights that misalignment between formal accountability and actual influence can create governance blind spots. This suggests that auditors should examine how decision authority is structured in practice when AI outputs are involved. For example, are overrides documented? Are AI-supported recommendations traceable in audit trails? And are deviations from system output systematically reviewed here? So the research does not prescribe specific audit procedures. Rather, it reframes assurance as an assessment of organizational embedding. From a literature-based standpoint, effective AI audit must therefore evaluate whether AI supports decisions remain constructible, attributable, and reviewable again over time. Beyond audit, these findings also have important implications for IT governance more broadly. The governance literature reviewed in this study shifts attention from isolated control mechanisms to structural alignment. While traditional AI governance frameworks define roles, responsibilities, and oversight processes, AI integration introduces new layers of influence within the structures. Several studies indicate that governance challenges often arise not because AI systems are unclear, but because their integration into authority hierarchies remains undefined. So, governance frameworks may specify who is formally responsible, yet AI outputs may significantly shape decisions without explicit procedural alignment. From a literature-based perspective, this highlights the importance of integrating AI-supported decisions into existing governance architectures. This includes clarifying how AI-generated insights enter board-level reporting, how risk classifications are validated, and how accountability is maintained across organizational layers. The reviewed research also suggests that governance must remain adaptive. AI systems evolve, data environments change, and decision logics may shift over time. Static governance models are therefore very insufficient. Instead, literature emphasizes continuous oversight mechanisms, cross-functional coordination, and iterative review processes. In this sense, AI governance is not an additional compliance layer. It represents an extension of existing governance principles into algorithm-supported decision context. Finally, the leadership-centered model also carries direct implications for information security. The literature also provides important implications for information security, but from a slightly different angle. Traditional AI security discussions focus on technical vulnerabilities such as data poisoning, adversarial manipulation, and model exploitation. While these risks are very significant, organizational research highlights an additional dimension: the visibility of AI-related decision risk within security processes. Several studies indicate that when AI outputs are treated as authoritative without structured review, risk signals may become less observable within incident management routines. From a literature-based perspective, information security must therefore consider not only external attack surfaces, but also internal visibility mechanisms. This includes examining whether AI-supported alerts can be challenged, whether overrides decisions are logged, and whether model limitations are documented within security governance processes. The research further suggests that effective AI security depends more on integrating model-related risks into broader risk management frameworks. That's isolating it within technical teams. In this view, AI-related security resilience is closely tied to how organizations structure oversight, escalation, and documentation around AI-supported decisions. Information security in AI-enabled environments becomes partly an issue of organizational transparency and structured dissent, not only of technical defense. In this final section, I would like to summarize the central insights of the talk and translate them into a small set of concrete takeaways for ISACA practice. I will then close with a short reflection and end the discussion. Let me summarize the key takeaways in a way that is directly applicable to ISACA-related domains. First, trustworthy AI is not primarily a technical achievement. It is an organizational outcome. Explainability alone does not guarantee accountable or governable AI-supported decisions. What matters is how AI is embedded into decision architectures. Second, leadership plays a structuring role in AI governance. Leadership determines how authority is distributed, how explanations are interpreted, and how uncertainty is managed. This means that AI assurance must expand beyond model validation. It must assess whether decision rights, accountability mechanisms, and escalation paths are clearly defined and operationalized. Third, AI governance must be treated as a dynamic capability. AI systems evolve, organizational contexts change, and risk exposure shifts over time. Governance frameworks must therefore integrate continuous oversight, structured review processes, and cross-functional collaboration. Finally, the central shift is this. The objective of assurance is no longer only the system. It is the AI-supported decision process. If that process is accountable, traceable, and reviewable, then AI becomes governable. If this is not, technical transparency alone will not prevent governance gaps. So to conclude, the central message of today's talk is that trustworthy AI is not achieved through technology alone. While explainability and technical robustness remain important, the literature consistently highlights that trust in AI-supportive decisions emerges from leadership-centered governance. In particular, governance structures that align decision-making, authority, accountability, and oversight play a decisive role in determining whether AI-supported decisions remain controllable and reviewable over time. At the same time, this field continues to evolve rapidly. AI systems are becoming more deeply embedded in professional decision-making, and this makes the leadership dimension of AI governance increasingly relevant. The research presented today represents just only selected insights from an ongoing research agenda that examines how leadership shapes trust, explainability, and accountability in knowledge-intensive environments. If you would like to continue the discussion or exchange perspectives, I would be very happy to stay in touch with you. I'm available for conversations around classical IT audit and information security topics. including C5 audits, NIS2 readiness, ISMS implementation, and also critical infrastructure assessments. In addition, I work on AI-related assurance, AI governance, and business transformation initiatives where leadership and technology intersect. You're welcome to reach out via email or phone or via LinkedIn, and I'm always open to collaboration from both research and practice perspectives. So thank you very much for your attention.
So thank you very much, Mark. It was a great pleasure to for your explanation. Oh, I got a lot of reactions here. Good. I got a couple of questions. So one question was, if explainability alone is not enough, what additional measures should organization prioritize to ensure trustworthy AI supporting decision making? Do you have any examples or something you would like to share for us?
Okay, yeah. In general, I would say, yeah, that the literature suggests that organizations should prioritize decision architectures rather than model transparency alone. So this means clarifying decision rights, documenting override mechanisms, and ensuring that AI-supported outputs remain reviewable within existing governance structures. So trustworthy AI therefore emerges less from a technical explainability and more from aligned authority, accountability, and oversight mechanisms.
That's good. And the next question is a little bit in the same area like you had before with the auditing. So how does the leadership perspective change the way AI should be audited? So to be around your 4 takeaways, do you have some additional points here?
Yeah, I would say, yeah, the leadership perspective expands the audit object from the AI system to the decision environment in which the system operates. So auditors should not only assess model transparency and the data quality, but also examine how authority is distributed and how overrides are handled, and whether AI-supported decisions remain constructible over time. So in this case, AI audit becomes an assessment more of organizational embedding rather than purely technical robustness.
Good, thank you very much. And our last question for today, what do you think is the biggest risk if organizations treat AI governance as a purely technical challenge?
Okay, yeah, I would say the literature highlights that the main risk is the emergence of governance blind spots. So imagine when AI is threaded as a technical tool rather than a decision-shaping actor, the influence may shift without corresponding judgments in accountability structures. So this can reduce risk visibility, weaken escalation routines, and also ultimately undermine organizational control, even when the system are technically explainable.
Good. Thank you very much, Mark. Then I wish you all a great Thursday.
Thank you.